All right, hey guys, so these are just the solutions to the questions you were supposed to try. So the first triangles there, you're able to prove them similar with angle-angle similarity and solving for sides y and z. Now, if you substituted into the ratio of the corresponding sides, you may have had your fractions or your ratios flipped, which is fine as long as they're both flipped. What you need to notice is that in this case, y is in the smaller triangle, so I also have this portion from the smaller triangle. There's 7's from the larger, 4's from the larger. And same over here, my variable z is in the smaller, so the other number on top is also from the smaller one. If you had one of your fractions flipped and you had small over big and then big over small, you wouldn't be cross multiplying it correctly. So when we come down here, another question, again, you can prove it with angle-angle similarity because of z pattern with those parallel lines. And here you're solving for b and x. So we get b is 18/5 and x you should have 35/5. So you'll notice with this one, the unknown b was in the smaller triangle. So I like to put the variable on top if I'm kind of selecting how to do this. So if I wasn't using those ratio of corresponding sides where it's automatically going to just substitute. So I have my b on top. And since b is in the smaller triangle, I have small over big for my orange lines there, those two corresponding sides. When I did this question then over here, and I'm trying to find x was actually in the larger triangle. So when I'm trying to write the other ratio, I actually ended up having to flip this because I had big over small just in the way I set it up. So you can be consistent if you want, always do small over big, that would be fine. You'll just have the x in the bottom when you cross multiply. It's really not a big deal. Or you can just go with the flow. So those are your numbers there. Last page, number 3, again, angle-angle similarity for the nested triangles. There's the trick in this one in that x is not actually a side on the triangle, but it's part of this side of the big triangle. So instead of having x or 15, but it's the combination of the two, x plus 15. So you'll see that that's what I've got there. Here I happen to put the x in the bottom. Could have had it on the top, but then that would flip this other fraction as well to 11/7. And then it would have been like that guy. So solving for y and x, we get fraction answers here for both of them. Oh, geez, 70. I threw an extra 0 on there. I just noticed it. Get that out of there. There we go. And then on the last one, down here, so in a lot of word problems that we see around triangles, we often see a lot of right triangles. You know, standing on the ground, typically we stand at a 90-degree angle. Our tree typically meets the ground at a 90-degree angle, so we can make the assumption that those two angles are the same. And then also the light reflecting off of a mirror surface and reflects back up. We can say that these two angles in here are the same, but they're also indicated they're the same with those scoops, little curves there. So how tall is the tree? So I set up my proportion. The tree side matches with the guy side, and then the 20 matches with the 4. If you wanted to write your similarity statement, your ratio of corresponding sides, you could have done that. I actually just noticed I didn't write my similarity statement, so I'm going to do that right now. So I have triangle C, B, so C and B. The third one would be P. And my small triangle is similar to A, B, and then in this triangle, it goes up to the top of 3 here to Q. So you can write your ratio corresponding sides as well. This is one where when I got down here, I realized it was a simple multiplication. So increase by 5, multiply by 5 here, and I got t equals 10. So that's it. I'm all done. See you later.